Okay, good morning to everyone. The yesterday's class, we were discussing about one problem. That problem, uh, I was given you as a homework, and I have explained how to solve that problem also. So, going to the problem, that problem is related to the Shields equation. How the Shields equation can be um, used to determine the velocity of in the sewer. Normally, that Shields equation is used to find out the non-scouring velocity. Uh, Before that, we have discussed some of um, uh, some of the equations related or empirical formulas related to the um, partial flow as well as the full flow. So we were discussing about this problem. So in this problem, you can see that some of the hints I have already given. That is, um, you can see. So here, the area is 50 square kilometer has already given, and the density of population of the town has given that it is 20 persons per hectare. Then I already said that how exactly it can be calculated with the calculations called 1 hectare is equal to 100 by 100 meters square. Then 1 kilometer is equal to 1000 meters. Then the average flow, that is rate of demand, they have given as the rate of demand that they have given 250 LPCD. The peak discharge is 1.5 times the more than average flow. It is given at is 1.5 times the average flow. This is very important, not the maximum flow. Then rainfall is equivalent to 8 mm in 24 hours. Then they said that it is all of which are runoff only. Then they asked us to calculate what should be the capacity of the sewer in meter cube per second, that is sewage flow, and to find the minimum velocity and gradient required, that is slope. You have to find out velocity as well as the slope. This slope is nothing but we can say it is the bed slope, not the side slope. Containing the coarse sand of 1 mm diameter through a sewer of 35 centimeter dia. The specific gravity of the particle is 2.65, and the value of K and F is K is 0.06 and F 0.03. Then normally the peak discharge can be calculated as 1.5 times the average flow. Then you have to find out the total Q, which is related to Q1 plus Q2. Then how we have to go ahead with this problem? First, our duty is to calculate the density of density of density of population, that is equal to so has given 200 persons per hectare. Then it should be first converted into 50 hectares. They have given area, that is 50 kilometer square. Then it is better to convert it into hectares. Now it can be calculated. So in this you can see that 50 is multiplied by 100. So it is because 1 kilometer square is equal to 100 hectares. That is why I am multiplying here with the 100 hectares. Then it should be multiplied by the 200 population. Then if you do that, you are going to get means uh, that is 1 lakh, 10 lakh, you are getting 10 lakh, 10 lakh they have given. Then it is per 50 kilometers square, or it is 50 into 50 into 100 hectares. 50 into 100 hectares. So total we got total 10 lakhs population. So we calculated population here. Once it is population has been calculated, then our job is to calculate the sewage flow. So then how it can be calculated? So then here you can see that this is the population 10 lakhs what we got 10 lakh. Then 250 it is rate of demand. Rate of demand. So then whatever we are getting, so it is 10 into 10 power 5 multiply by 250 liters per day. So then it has to be calculated, converted into whatever the value it is there, it has to be divided by converted into meter cube per second. Then how exactly we are going to convert it? So then day it is 24 hour into 60 into 60 means 60 minutes 60 seconds. Then we have to convert this into meter cube per second, actually meter cube per second. Then it is multiplied by 1000. Why you are multiplying? Because 1 meter cube is equal to 1 meter cube is equal to 1000 liters. So 1 meter cube is equal to 1000 liters. That is why I am dividing with the 1000 here. So once you will get, so you will get this value, that is 2.893 meter cube per second. So then always they said that always you consider the peak factor. This is peak factor is 1.5. So then 1.5 multiplied by, that is 2.8893. Then this is equal to 4.34 meter cube per second. So with this, so we got the maximum demand itself. Whatever we are getting maximum demand. Then the next job is to find out the stormwater flow. Stormwater flow. Then it can be calculated by multiplying. It's a very simple equation. By multiplying the intensity of the rainfall, that is I multiplied by the area. It is a simple equation because we are till now we have used some of the rational method and as well as the empirical formulas, but he has not given any uh, equations to find out it, that is to find out the c value, because we have q is equal to c I a divided by 360. Here he has not given the c value. You're not supposed to assume also. So then we have to consider only these two now. So when you are considering these two to calculate the storm water, that is we have assumed that is q2. So q2 is equal to I into a. So when we are doing that I a, so area first, area is 50 kilometer square is there, that we have to convert it into meters, meter square, 1000 into 1000, because 1 kilometer is equal to 1000 meters. So then we got 50 here, this is completely related. Then this is kilometer square by actually whatever the area it is there, or then it should be multiply by multiply by 8 mm he has given, very important. Density of rainfall he has given. Then if you want to convert this into meters, then what I have to do is that I have to divide it by this only 1000. That only he has did here, very important. Okay, then whatever it is there, 8 mm per 24 hours yes given. So then this 24 hours, whatever it is there, 24 hours, 24, because 24 into 60 into 60, because you are converted into seconds, because we need the q2 value in meter cube per second, meter cube per second. Whatever the q2 is there, you should get in meter cube per second. So that is why now here the unit is now meter square, because meter, this we are converting into meter, so completely it is meter cube. Then this we are converting in seconds, so then total we can write in this way: 50,000 8 mm divided by 1000, 24, 60 into 60. Then total will get, that is 4.63. So means then total flow Q1, Q2, that is equal to 4 point previous value plus 4.63. So we will get, that is Q is equal to 8.97 meter cube per second. Then we calculated whatever he has asked, that is Q. That is first one, sewage flow. Then he has asked using the sealed equation, we have to calculate it. Then that is minimum velocity, that is equal to, it can be calculated with this equation. Then substitute all the values here. 8 and substitute the K value, this is K value, F value, specific gravity, and S divided by 1. This is acceleration due to gravity 9.81. ds has given 1 mm. It is better to convert it into meters. That is why. So divided by 1000 made it. Then V is equal to 0.51 meter per second. Very important. This conversion is for mm to meters. Then we have calculated the minimum velocity. So this is the solution for this problem. Then he asked the hydraulic mean depth. Then hydraulic mean depth can be calculated because they asked to calculate V also. Once they ask the V, so we have the formula called 1 by n r to the power 2 by 3 s to the power half. So then if you want to calculate the hydraulic mean depth, so you have to use this formula, wetted area by wetted perimeter. So then wetted area for circular sections, it can be calculated with a formula called pi d square by pi d square by 4 and divided by pi d. This is wetted perimeter and this is wetted area. So then we got, that is d divided by 4. Then once you got r, so we have to assume n. This is, we have to assume that is for the Manning's constant. Then the slope we have to find here. Slope, because he asked us to calculate slope. We got the velocity with a Shields equation, the previous whatever it is there, Shields equation. We got this 0.51, then 1 by n r to the power 2 by 3 s to the power half. Then we got this much. Then we are getting the bed slope. Bed slope is equal to 1 in 104 10, that is 1040. Therefore, we got V, we got S, and we got Q. So this is the complete solution. Okay, the next problem we will cover it in the next class. Thank you.